Good afternoon, everybody. I'm Patrick speaking live from Indian Cyber Security Solutions. And today we have Mr. Anish Rajan. He is currently a student from Indian Cyber Security Solutions and would be speaking about his project in Python data structure and the concept of OOPS. Now, OOPS is known as Object Oriented Programming, which is a programming paradigm based on the concept of objects, which are data structures that contain data in the form of fields or attributes, and code in the form of procedures or methods. Now, I hand over the platform to Mr. Anish Rajan, who will be speaking more about the topic, helping you to understand the concept of OOPS more easily. Before we move on to the show, I would like you to please like our videos on Facebook as well as on YouTube. Also, to share it amongst your friends so that they know more about this concept easily. Also, if you love the video, then do subscribe to our channel or YouTube channel and press the bell icon so you don't miss an update. Anish Rajan, please take the show.
Thank you very much. Good afternoon, everybody. Good afternoon. So, as you have already seen, as you've already heard, this is my topic for today's webinar. So let's move on. So
Anish,
basically,
can you be a bit louder?
okay. Hello, is that okay?
No, a little bit more louder. You're not so audible.
Okay. Hello, is this okay?
Yeah. Please be a bit more louder.
Hello, is this okay?
Uh, no, your tone is still the less. I think you need to speak a little louder.
Actually, I'm holding the microphone just near my mouth.
No, I think your voice is not loud.
Hello, is it okay?
Yeah. This is now louder.
Okay. Thank you very much. Okay, so let's begin. So basically, in today's world, we use a lot of websites, we use a lot of apps on our phone, we use a lot of websites to order things, purchase things. So all these websites, all these apps are basically, they are made by writing code. So the code is written and that code is executed. It's compiled, it's checked for errors, and then it's executed. And that's how those applications are made. So now what we are going to study now, what we are going to see now is that the OOPS concept and Python data structures, which will come later on. So whenever you are doing programming, in programming, how you write your code is a very important thing. Why is that important? Because certain codes, for example, I might write a code in 4 lines and somebody else might write it in 10 lines. So that means my code is better than his because I have written it in less number of lines, and I have done something which has costed me less time. Okay, so basically what happens is that the best code is not that which gives perfect results, but which is more organized, clear, and lucid to understand. So if I and 3 other people are working on the same project, if we are writing something, let's say for example we are making an application. We 4 of us are making an application, and 4 of us are making the same application. So we are writing code. 4 of us are writing code, isn't it? But somebody might write it in 50 lines, somebody might write it in 100 lines, somebody might write it in 200 lines, and likewise. So everybody's code is going to run in the end. I might have 10 errors, so I fix them. Another person might have 50 errors. He takes the time and he fixes it. He gives his time and he fixes it. But basically, the person whose errors are least and who has written the code in the least number of lines is the person who will basically be benefited from that, isn't it? Because he has written it in the most perfect way. So this writing code, basically, this is not a special feature of any programming language. Okay, this is not a special feature, it's just a way of writing code. So it's the way of writing code that makes it easier for people to understand, the other person to understand. Okay, so now we come to what is OOPS. So OOPS basically stands for Object Oriented Programming. Okay, now what is Object Oriented Programming? It's basically a style of writing code which makes the code well organized and easy to deal with. So obviously, a code which is well organized and easy to deal with is much better than a code which is disorganized. So this it's much easier, and well, it's much easier to understand for someone who is who hasn't written the code. So for someone who hasn't written this code, it's much easier for him to understand what's actually happening. Okay. Now then what happens is that OOPS introduces the concept of class and objects, which is very much relatable to our real world. So we will see how this is relatable to our real world. In a few minutes, we'll see how it's relatable to our real world. So now we come to what is class and what are objects. What are class and what are objects? So a class is the basic design of the blueprint which contains core properties and functions. Okay. So what does this mean actually? So what is a blueprint? A blueprint. So for example, if we have the blueprint of a building, we can create that building again. For example, let's say Taj Mahal. If we have the blueprint of the Taj Mahal, we can create another Taj Mahal, which is an exact replica of that Taj Mahal. We can't create the same Taj Mahal if we don't have the blueprint of that, the exact blueprint. So what happens is that the blueprint is basically the basic design which contains all the core properties and functions. So that is what a class is. A class is basically the blueprint which creates objects. The class contains all the properties and the functions which are required to create an object. So let us see this example here. A car company is manufacturing cars. All these cars have certain basic parts in common. So basically, the car company is the blueprint, which is manufacturing different cars, which is manufacturing. These cars are basically the objects which are being manufactured by the car company. So here the car company stands as the class. So what will happen is that these different cars will have all these chassis, axles, differentials, all these parts. Every car is going to have these parts. So these are the core properties. Okay, which every car that is manufactured from that company will have these parts, isn't it? The design of the car may be different, but every car will have this chassis, axle, and differentials. These are the common core properties of every car. Okay. So next we come to what is an object. So as I already said, an object, as you can understand by now, that an object is an entity of a class. So a class creates the objects. An object is the entity of the class. So let's see this example. A car company manufactures different cars. These cars are all objects which are being created from a basic blueprint. So that is what I said. It's being created from a basic blueprint, that is a class, and they are all different from each other. One more thing about objects is that, which I want to mention here, is that an object is always different from another object. It's a different entity. So car company is manufacturing cars, but every car is different from the other car. It's not related to the other car in any way. Okay. So now we come up to what are the components of a class. So a class is basically made up of two components: attributes and methods. So let's see what these are. So attributes are what? An attribute is a feature of a class. So an attribute is basically a feature of a class. So I'll be able to explain this better with this example. Like, see, for example, all luxury cars have two-seater arrangement. So that's a feature of luxury cars. All luxury cars have heated seats. So heated seat is a feature of luxury cars. So these cars are objects. Cars are basically objects which have been created from the class, as I mentioned earlier. And now these objects have these attributes, that is the features. So this luxury car has this heated seat, or it has this two-seater arrangement, or different attributes. So besides this, there can be many attributes in a class. So obviously a class can have many attributes. Okay. And now we go to methods. So method is basically a function which is used to access these attributes. So what a method does is that you have these attributes in a class, and the method helps you to access those attributes. So again, we go to this example. To heat up the seats, you press the relevant button on the car, and this in turn activates the mechanism to heat up the seats. So you have heated seats in your car, right? But how do you access them? How do you turn on that facility, that heated seat? By switching on the button, or pressing on the button, by pressing the button. So that in turn activates the internal mechanism, and that is how so basically that that button helps you to access this attribute or this feature of the car. Okay. Now we come to what are the four pillars of OOPS. So this OOPS concept is basically based on four pillars. So there are four basic ideas on which this theory, this concept has been developed. The first is inheritance, second is polymorphism, third is encapsulation, and the fourth is abstraction. So we'll see now what these four words actually mean. So first is inheritance. Inheritance is a property where a class reuses the implementation of another class. Okay. So obviously that definition didn't go so well. So you need to understand it with an example. So let's see this example here. If I have to explain what a vehicle is, there are two ways. Okay. So I explained that a car is a type of vehicle and it drives on a road and consumes petrol. But when I explain about a motorcycle, I will again have to describe that it moves on a road and consumes petrol. So, for example, let us say I am explaining to a child what a car is. Okay. So I explain to him that a car is a vehicle and it drives on the road and consumes petrol. But again, now what happens is that when I need to explain to him about a motorcycle, again I have to give that same description of what a motorcycle is also a vehicle, it moves on the road, it consumes petrol. So I have to again say the same thing to him. So basically I have to repeat myself every time I explain a car or a lorry or a bike or any kind of vehicle. So instead of this, what I do to avoid this repetition, what I do is basically I first explain what a vehicle is and then I explain that a car or a bike, this is a type of a vehicle. Okay, so that is what is inheritance, is that the parent class inherits properties. I'm sorry, not the parent class. A class inherits properties from another class, so that you don't need to rewrite those attributes and those methods and those functions, everything again. So you are just inheriting that idea to the next class. Okay. Now we come to abstraction. So what is abstraction? Abstraction is providing attributes and methods to an object that are useful for the task at hand. So again, let's see this example. A car has a lot of attributes like engine type, number of miles traveled, age, color, so and so. But now let's see this. If I want my friend to look for my car, I'll not tell him these. So when I want my friend to look for my car, supposing we have gone to a parking lot and I want my friend to look for a car. So what will I do? The easiest way to make him understand which will be my car is that I tell him the color of my car. So that is the best way to make him understand which is my car. On the other hand, now when I speak to a mechanic, okay, he'll not be interested in the color. So when I'm speaking to a mechanic, what happens is that my mechanic is not interested in knowing the color of my car. He is interested in the specs of my car. So how many miles my car has traveled, what is the engine type. So he's interested in that. He's not interested in the color. So basically what happens is that abstraction provides attributes and methods to an object which are useful at the task at hand. So according to the task which is at hand, okay, we have to provide the attributes and methods so that it's able to understand we are able to understand properly what we are doing. Okay. Now we come to encapsulation. Encapsulation means reducing dependencies between objects by hiding the internal representation of an object behind specific methods. Okay. So what happens is that now when you start a car, a series of events occur. So these are the series of events that occur: initial spark, fuel injection. First the spark ignites, then fuel is injected, then the combustion of fuel takes place, then that drives the pistons. Okay, but what happens is that we are unaware of all these things. So the mechanics, we are unaware of all these things. So what happens is that now, for example, when we are going to drive a car, we just start the car and drive it. So we just know the basic functions of a car: start it, press the accelerator, press the clutch, or whatever is needed, and we drive it. So we don't know the mechanics behind this. Okay, so what happens is that when these cars need to be upgraded, the person who is upgrading, or the company who is upgrading the car, he knows that the new car which he is going to make, the person who will be using that car, he just knows how to start the car and use it. That the person who is purchasing the car does not need to know how the car works or the mechanics behind the car. So this way, what happens is that the car company or the car manufacturer, there is a line of separation between the user and the producer. So the producer shields all these things from the user. The user just uses the car. He knows how to use it. So in other words, what happens is that any change in mechanics does not require the driver to relearn driving. So you don't need to relearn driving when you're buying a new car. So that is what is encapsulation. You are hiding these details from the end user. So basically hiding internal representation of an object behind specific methods. That is what it means. Okay. Now we come to polymorphism. So polymorphism is basically a way of allowing similar operations to be grouped together under the same name. So now what it means again. So if you have to explain to someone how to start a vehicle, even though there are a variety of vehicles and the method of starting them is almost similar, just start the engine and speed up. Okay. So even though a car and bus are not the same, okay, the method of starting them is almost same. So polymorphism basically means allowing similar operations to be grouped together under the same name. So basically all these vehicles are different vehicles. They are totally different objects, totally different vehicles. Okay, but all of them start in the same way and they move in the same way. Okay. Now we come to the next topic of my webinar, that is data structures. So what is data? Data is a collection of facts. Okay. So my name is Anish Rajan. I live in Bihala. I live at so and so address. So these are all data about me. All these are facts and these are all data about me. Okay. So data can be of two types: qualitative data and quantitative data. So qualitative data. Let's talk about qualitative data. So this qualitative data is basically non-numerical data. So this is an example of any type of data. A tiger eats meat, it's yellow in color, it lives in the wild. So all these data are non-numerical data. They do not have any kind of numbers associated with them. So basically qualitative data is used to classify or categorize something. So we classify or categorize something using qualitative data, like the way I said about myself, right? So that data was all qualitative data. So I just gave information about myself to classify myself. Okay. So like this example, then the last line states that all these above points categorize tiger as an animal. So all the three lines categorize tiger as an animal. Next we come to quantitative data. So this kind of data is a numerical data. Okay. So obviously by the name we can understand that numerical data, obviously it will involve numbers. Okay. So numerical data will always involve numbers. As we can see in this example, a book is containing 250 pages. It was released in the year 2015. It is priced at so and so, rupees 400. Okay. Now this quantitative data can again be of two types, that is discrete and continuous data. So discrete data means involving continuous whole numbers, and continuous data may take any value. Okay. So discrete data will always be whole numbers. So for example, the numbers of family, the number of family members, this cannot be decimal. But on the other hand, continuous data, this kind of numerical data, this kind of quantitative data can be a fraction, it can be a decimal. So for example, the height of a person here is 172.5 centimeter, which is a decimal. So this kind of data can be in decimal. Okay. So for example, okay. Now for data structures. So what basically are data structures and why do we need them? Okay. So for example, a single piece of data is called a data item. So for example, the price of a share. I say a price of the share. This price of the share is 45 rupees. So that is a data item. So that is data about that share. Now, what happens is that why would we need a data structure? Why would we need this at all? Why do we need data structures? So, for example, I need to invest in shares. I'm going to invest in shares. So I look up my computer, I open my computer and I check the website, and I see that the share price is, it's currently today the share price is 45 rupees. But I won't be investing in that share just like that. I'll be checking the entire history of that share. I'll be checking how long, for when did that share do well, when the price was high, when it was low, how, what is the average price of that share in 10 years. I'll be checking all these things before I invest. So there comes the need of data structures. That is where we need data structures. So data structures, basically what happens is that we use data structures to store data. We use data structures to store data. And why do we need to store data? We need to store data for this reason. That is, we need to store data so that we can take it out, we can use it to compare, we can use it, access it, we can basically store it and access it as and when we need it. Okay. Now, in Python, basically, we have 5 kinds of data structures. There are basically 5 types of data structures in Python: string, list, dictionary, tuple, and set. Okay. And one more thing which we should note here is that these data structures can hold any type of data. Okay. So basically, what it means is that, like, for example, in a in a list can hold another list, a list can hold another list. For example, in string we can store any type of data, a data which is an integer, data which is a float, or data which is a character. So this is what it means, that these data structures can hold any type of data. Now we come to what is immutable and mutable. So basically, immutable data structures are those data structures that cannot be changed once they are created. So we cannot add or remove data. And the example of immutable data structures are tuple and string. And mutable data, obviously that means mutable data structures are those data structures that can be changed, which can be, means we can add data items to it. We can add or remove data items to it. And the example of that is dictionary, set, and list. Okay. Now, why these two are classified like that, why the 5 data structures are classified into these 2 categories, is because in some operations, in some cases, we need to store data and we don't need to change that anymore. But in some cases, we store data on a temporary basis and we need to keep changing that. So that's why there are some data structures which are immutable, and there are some data structures which are mutable. Okay, so we come to the first type of data structure, that is strings. So basically, it is basically a series of characters. So string is basically, it is the simplest type of data structure, and it is basically a series of characters. Okay. And one more thing which we need to note here, all these data structures in Python, they are indexed from 0. So what that actually means is that when we create a data structure, its indexing will always start from 0. So the first, when we create a data structure, when we add the first data item to it, its index will be 0. Okay. So now in strings, basically, so these are a sequence type of data structure. Sequence type of data structure means that items are added sequentially. So we add one item, then the next item is added after it, then the third, then we add another item, and this item is added after the second item. So these are, it is a sequence type of data structure. Okay. And as I said, this is the simplest type of data structure. Okay. Now we come to list. So the list is the most widely used data structure. Okay. And it is also sequence type of data structure, and it can grow and shrink. So a list is not like a string, it can grow and shrink. So it can increase its size and it can decrease its size also as per the requirement. Okay. Now the one of the reasons why it is the most widely used data structure is because it can be sorted. So, for example, I store certain names into a list. I store the names of my friends into a list. Not friends. For example, I'm a class teacher. I store the names of my students into this list. So what happens is that I can sort. It can be sorted. So I can sort it. I can sort it and get all the names in the alphabetical order. So this is just one application, one feature of the list. Okay, we'll discuss more features later on. Okay, and one more thing, as I mentioned earlier, also a list, it can contain different types of data. So a list can contain another list. It can contain float type of data. It can contain a string. It can contain integers and so on. Okay. Now we come to a tuple. Okay. A tuple is basically, it is a sequence type of data structure. Again, it's a sequence type of data structure. But a tuple, it is faster than list since they are immutable. So what happens is that in a tuple, it is easier, the accessing of a tuple is easier than a list. Okay, a list, maybe it can grow and shrink, it has that advantage, but over here a tuple has an advantage over the list, which is this: it can be it's faster than list. So the access in a tuple is easier, it's faster. Okay, and tuple, it is basically used for fixed data. It is useful for fixed data because a tuple cannot be, the data items in tuple cannot be changed once they are inserted into it. Okay, and it can be homogeneous or heterogeneous. So again, the same thing: homogeneous data or heterogeneous data can be inserted. Okay. Next, we come to sets. Okay, so basically, sets. What is a set? Basically, a set is basically this kind of data structure. See, every kind of data structure, as we saw the list, strings, tuples, all these three data structures we have seen, all of them have some kind of use. Okay, that is the reason why they are, some is mutable, some is immutable, some you can access data fast. So everybody has some kind of advantage over the other. So in set, what happens is that these kind of data structures are basically used for mathematical operations. These set data structures are very useful for mathematical operations. Okay, that is the primary, one of the primary advantage of sets. Okay. So, and sets have one feature is that they do not store duplicate items. So when you input duplicate items into a set, it will not store those items. Okay, and set stores data in an unordered form. Okay, sets are storing data in an unordered form, so it's not sequential over here. So when you store data into a set, so for example, I have a set, okay, and I'm inserting data. I'm inserting one data item into that set. What will happen is that that data item, it is not like the data item will go at the last position. So the second last item is there, and after that the new item will go. It's not like that. The item can be placed anywhere. So that is why it stores data in an unordered form. And as I already said this, that it's useful for math operations. And this, again, the fourth point here is that its accessibility is faster compared to list. Okay, so basically the list, why its accessibility, even the previous case also, why I was saying that, because accessibility is maximum, it's faster because it cannot be changed, the size of it cannot be changed, whereas the list, it can increase, it can decrease. Of course, if it decreases, it's okay, but if it's increasing, the size of the list increases, then obviously it's becoming bigger and bigger, so its accessibility time and everything will be shortened. Okay, and now we come to the last data structure, that is the dictionary. Okay, so as the name indicates, dictionary. So let's take the English meaning of a dictionary. A dictionary in English means what actually? What do we use it for? We use it to search for the meaning of words. Okay. So likewise, in this dictionary, in this data structure dictionary, what we basically do is that we have key and pair values. Okay. So for example, in this data structure, this dictionary data structure, what we do is that we store a particular key, a particular item, and it has its own values. So for example, let me give a very crude example here before I illustrate all the other points in this section. is that, for example, I have a purse. Okay, so in that purse I have some money. Okay, so in that purse, say for example, I have 500 rupee notes. I have four 500 rupee notes. Then I have a collection of money, isn't it, in my purse? Four 500 rupee notes, 200 rupee notes, six 10 rupee notes. So over here, in this example, the purse is the dictionary, and these 500, rupees, all these notes are the keys. Okay, and this key has some value associated with it. So this 500 rupee note has a value 3 associated. That means we have three 500 rupee notes. So those are the values. So this is the way keys and values are linked or associated to each other in a dictionary. Okay, I'll explain this more in detail later on. So it is basically a bag of values, each with its own label. So as I said, as I gave this example, we have a bag, we have a purse, and each has its own label. That means 500 rupee note, 100 rupee note, 10 rupee note. So all these different labels we have, and each label has its own value. That is the number of notes. Okay, it contains keys and values associated with those keys. So this is what I just explained, the concept of what are these keys, what are these values, and how they are associated with each other. And again, it stores data in an unordered form. So this is what is a dictionary. Okay. Now we come to a little bit of coding. Now we'll have a lot of coding actually. I'll just show codes related to these different data structures. So the first, we have strings. Okay, so basically the first code here is written to create a string. Okay, so this is how we create a string. So we'll write that string within quotes and then store it in a variable called student, and then we'll print that variable. Okay, so now how does the computer understand that Anish, this line or this word which is written, is a string? So how does the computer know that I want it to be saved as a string? That is by these quotes. So as you can see, those two quotes, the anything which is written between two quotes will be treated as a string in the computer. Okay, so next we have the indexing of a string. So this code here gives the character at a particular index. So the indexing of a string, with the help of this, what we can do is that we can find a particular character in a string. So like here I have found the third character. As you can see, 3 gives S. Okay, because why I mentioned before, in all the data structures, the indexing starts from 0. So third, when you write 3 there, it will give you S. It will not give you the since the indexing is starting from 0. Okay. Now next we have the length function. The length function, what does it do? It gives us the length of the string. So when you write this code here, you can see it's giving 5. So 5 is the length of the string. So this length function helps us to determine the length of the string. So this is basically one of the functions of the strings, which gives us the length within just one by writing just one code. Okay. Now we come to an important part, that is slicing of a string. So slices a part of the string. Slicing, what does it basically mean actually is that by writing this code here, student, and then within the brackets 0, and then what does it basically mean is that we are taking a part of the string. Sometimes we don't require that entire data structure. We require a part of that string. We require just a part of it. So we need to slice that string. So this is the code to slice the string. Next we have concatenation. So as the word indicates, concatenation means joining. So here we join two separate strings. So we join two separate strings and make it into one string. So as this example, it's very clear here. The code is very clear. James and Watt are two different strings, and we are concatenating them and printing them. Okay. Now some important functions of a string, that is the count function. So these are some. Now we are going to discuss some important functions of a string, okay, which are very important functions because these help us in many ways. So basically now see we have a string by the name of sentence, and there is a sentence there. Now what I want to count the alphabet E in that string. So then I use this count function. So this count function very easily gives me the the number of times E has appeared on that string. So this is a very one of the important functions of a string that helps us to count any character or digit or any kind of variable. Sorry, character. Okay. Next we have the indexing. Okay, so this index function, what does the index function do? The index function, what does it do is that it prints the index of a particular character. So basically what it is doing is that I want to find the position of a particular character in the string. So that this code will help me and it will give me the position. Okay. Now next we have the split function. The split function, what does it do? It splits the string. So here you can see that this is a complete string. The monsoon has arrived in Kolkata is a complete string. It is one complete string, and that means it's a one complete string. So there is no breaks in between. Okay, there is no breaks in between. When you ask the computer to print line, it will print the entire string. There's no breaks in between. These spaces like the and monsoon, there is a space in between the and monsoon. That is also treated as a character. So a string is one complete variable. Okay, but now what this split function is doing is that it's breaking the string into parts. It's splitting it into parts, and it is storing it here. So we can see that the has been separated, monsoon has been separated. Again, this is also a very important function of string, because it's helping us to split it. It's helping us to split the string. So for example, if we have a lot very big string, we can split it into parts. Okay, and likewise, as there is split, there is join. So we use the join function, and then we join back all these words. Okay, all these words together, and we get back the string. So actually everything has its own application. Somewhere we require to split, somewhere we require to join, somewhere we require to find the index. Okay, now we come to the membership operator. So the membership operator, what does the membership operator do? It checks whether a particular character is part of a string or not. So for example, we had this line here, the monsoon has arrived in Kolkata. So now we are checking whether monsoon is a part of this string or not. So is monsoon in past line? Yes, it is. So past line, this monsoon has been, this entire string has been joined again, and it has been saved in monsoon. It has been saved in monsoon. And now we are checking whether monsoon, is it a part of that string? Yes, it is. And now we come to iterating through a string. Okay, so iterating means basically means printing one after the other. So we have this string, we are printing it, we are just printing out. Basically, we are iterating through a string. So we are going through each and every character of a string. Okay, so when we are printing, we are using the for loop. We are using the for loop here and printing the name string. What we are basically doing is that we are going through each and every character of the string. So as you can see, Anish has been printed. Then there is a space, and then there is a Rajan. So that's why I was saying that in a string, everything is part of a string. Even that space is also treated as a character. It's one complete string. And then we are iterating through the string. We are going through each and every element of the string. Okay. Now we have certain specific string functions. Okay, so there are certain specific functions which are there for a string. These functions are for a string, specifically for a string. So these are lower, upper, strip, L strip, R strip, capitalize, title, replace, and find. Okay, so now let us see what these functions are. So the lower function. The lower function, what does it do? It changes a string. It changes the string completely into lowercase. So this is a very small string actually, just Anish Rajan written there. But even though you can see that the capital A and the capital R have been changed to lowercase. So that is what this function does. So even if I write something entirely in caps, it will change it to lower. Okay. And similarly, the uppercase, you can see now it is more evident. So when I'm changing here, I'm changing everything to the uppercase. So Anish Rajan is written and it's changing, the upper function is changing everything to the uppercase. Okay. Now what does the strip function do? The strip function removes spaces at the beginning and end. So if you notice properly, you will see that I have written Anish Rajan, I have written the string, but there are two spaces in front and in the first and in the last. Now the strip function, what is doing is that it removes the spaces which are at the beginning and at the end. So that is the job of the strip function. So likewise, the L strip and R strip will remove the spaces from the beginning, and the R strip will remove the spaces from the end. So that is what is evident here. And what does the capitalize function do? The capitalize function, what it's basically doing is that it makes the first character of the string capital. So the first character of the string becomes capital. So in this string, the first letter, that is T, that has become capital. Next we go for title. So the title function, what does the title function do is that it makes each and every word of the string, the first letter of each and every word of the string capital. Okay, now how does it understand that today is a different word and good is a different word? By the spaces. That is by the spaces. It understands because the first letter of the string is being made capital, then it's looking for a space. When it finds a space character, then it makes is, that is the I. So that is how it understands. Okay. Next we have the replace function. The replace function is basically a very, very important function. We can replace any character within the string by another character. So as you can see, I have replaced A by E. Excuse me. As you can see, I have replaced A by E here, and so the entire sentence, wherever A is there, it is being changed to E right now. Okay. Now, next we have the find function. So the find function, what does the find function do? It finds the position of a character. So in this string here, we are finding the position of Y, and it shows us that the position of Y is 4. Okay, so that was it for strings. Now we'll come to list. Okay, so basically again the first syntax here, the first code here is for creating a list. So this is the way we create a list within the square brackets. We give the name of the list and we create the list with the square brackets and we write the items. So these are all items of the list. Tea, sugar, flour, milk are all items within the list. Okay, so now next we have the indexing of the list. So again in the similar way, what happens is that here now when we write this the name of the list and within square brackets, if we write we write 2, it gives us the second element of the list. It gives us the item at a particular index. So here again 2 will mean flour because the indexing starts from 0, so 2 will mean flour. Again the length function is applicable in list also. The length function gives us the length of the list. So within this list there are 4 items, so the length function is printing the length of the list. Similarly, likewise in list also we have slicing. We can slice a list and take out, extract. We can slice a list and extract a part of the list, like what is done here. Tea and sugar have been extracted. And in the list also we have concatenation. We have the concatenation operator where we can join 2 lists. We can join 2 lists and make a new list. Okay. These functions are similar, somewhat no, they are similar to strings. So again, we have the count function where we can count items in a list. Okay. And the index function here, index function, what does it do is that it gives us the index of a particular item in the list. Again, the membership operator and the iteration operator. So membership operator, again, like strings, it will check whether this particular item is a part of the list or not. Okay. And the iteration operator is the same thing. It will iterate to every item of the list. Here, basically, we are again using a for loop and printing the items of the list. Basically, this iteration operator uh, what I'm trying to explain from the iteration operator, what I'm trying to explain by iteration is that, like, these list and strings, these are both sequence type of items. Sequence type of data structures. So that brinjal, capsicum, cabbage, all these items are being accessed sequentially and they are being printed. So that is, they are being iterated, they are being accessed sequentially and being printed. Now again, we have certain functions, list functions, which are specific to list. We have certain functions specific to list, that is append, clear, copy, extend, insert, pop, remove, reverse, and sort. Okay, so let us go through these functions now. So the append function. So the append function, now lists are mutable, so they can be changed. So what is the job of the append function? The job of the append function is to add items to the list. Here, like we can see, this is a list, and then we add one item to the list. That is, we are adding sheep, this item to the list, and then we see that that item has been added. Now clear, what does the clear function do? The clear function empties the list. So once you use the clear function, the entire list becomes empty. It becomes freed of items. And the copy function, what does the copy function do? The copy function basically copies an entire list to a new list. Okay, so sometimes what happens is that as the need arises, we may have to copy the list to another list. So basically what this copy function is doing is that it's copying the entire human list to man, and then we are printing. So now the man, this list name man has all these items. Next is the extend function. Excuse me. Next is the extend function. So the extend function, the job of the extend function is to add multiple items to the list. So for example, we want to add 2 or more items together to the list. That we cannot do by the append function. We have to use the extend function. And so as you can see that here I have added these 2 items to the list by using the extend function. Next is the insert function. So the insert function, it inserts an item at a particular position in the list. So for example, in this function, we will need to specify the index and the item. So index is 2 and the item is face. So face has been inserted in the second position of the list. Okay. Now we have the pop function. So what does the pop function do? The pop function will remove the last item of the list. Okay. So by default, whatever is in the list at the last, that will be removed. This pop function will remove the last item. Next, we have the remove function. The remove function, what does the remove function do? The remove function will remove any particular item from the list. As you can see that I am removing this nose from the list, from this previous list actually. The nose is being removed. Okay, and here we have the new list without nose. Now we have the reverse function. So the reverse function reverses the order of the list. So for example, whatever was at the last, the entire order will be reversed and the last item will now become the first item. Now we have the sort function. The sort function is a very important function of the list. Okay, that is one of the main functions why we use a list. Okay, so the sort function, what does it do? It will sort the list. It will sort the list. If the list is like in this case, the list is containing it's containing words, it's containing alphabetical data. So here it will sort it in the form, it will sort it in alphabetical order. For example, if my list contains numbers, then it will sort it in the numerical order. Now we come to tuples. So tuples, just I want to remind you, tuples are immutable data structures. So they cannot be changed after being created. Okay, but tuples, as I mentioned earlier, tuples have some example advantages. That's why they are being used. Okay, so tuples here, this is a syntax to create a tuple. So here, this is how we create a tuple. Now, when we create a tuple, the important thing to note is that whenever we're creating a tuple, we are creating within this bracket. Okay, so this is what differentiates it from a list. So if we were creating a list here, we would mention it. We would mention it within all the items. We would mention within a square bracket. So here the syntax for creating a tuple is that we mention it within, we mention all the items within a bracket. Okay. So then again we have the index function, which gives you the index of an item. So here number is the tuple, and we get at index 2 we have 1. Okay, so just a second. Okay, sorry. So yeah, the index function is basically giving you the index of the item. Okay, it gives the index of an item. So next we have the counts. So the count function will again give you the number of counts, number of times of item has appeared in the tuple. Okay, so that was it. That was for tuples. Now we come to sets. So sets, as I mentioned earlier, sets are most useful in mathematical operations. These are basically used for mathematical operations. Now when we see we will slowly see the functions of sets, and that will make you understand why it's used for mostly used for mathematical operations. Okay, so the way to create a set is like this. We use it within these curly braces, and we give the items. Okay, and that creates the set. So this is a syntax for creating sets. And now if we want to add an item to a set, we do it by adding it in this manner. Okay, so now one thing, if you notice here, is that orange has been added in the third position, whereas the original set was apple, banana, and grapes. Okay, so orange, obviously orange should have been added in the last position, but that is what doesn't happen in sets. Sets contain data in unordered way. Sets do not have data in an ordered way. They store data in an unordered way. So anything you add will be placed anywhere. That is why it's not sequentially, it cannot be accessed sequentially. So this is one of the disadvantages of set. Okay, so next we have the clear function. The clear function, what it does is that it empties the set. So as you can see, it's very evident from here that I'm using the clear function and the set has become empty. Okay. Now we come to the specific set functions. As you can see now, that difference, these are the specific set functions. Difference update, intersection update, is disjoint, is subset, is superset, symmetric difference update, and union. So these functions, these are the set operations or the set functions which are basically make it very useful in mathematical operations. So let us see what these functions are. So the difference operator or the difference function. So what does the difference function do? It removes the unwanted items and returns a new set. So here you can see that we have two sets, X and Y. Okay, so X contains certain items, Y contains certain items. So what happens is that we are taking the difference of X and Y and we are storing it in a new set. Now this new set contains what? It contains cherry and banana. Okay, so basically the common item here, that is apple, within the two sets is being removed, and the items which are in X, which are in the first set, are being moved to a new set. So it's taking difference. Okay, this is not exactly like the numerical difference, the difference of numbers which we use, but this is a difference of sets. So that's why it's like this. The apple item is being removed, and then whatever is in the first set, it's being transferred to the new set Z, and that is being printed. Now what does the difference update method do? It removes the unwanted items from the original set. So it's the same thing. Both of these are basically the same thing, but in the next case here, the difference update case, what is happening is that in the original item, the original set is being printed. The original set is being printed. So that is what is the difference here. The original set is being printed. And in the first case, what was happening is that the items are being moved to a new set, that is Z. Okay. Now we come to the intersection function. So what does the intersection function do? It returns a set that contains items of both sets. So as you can understand, intersection function, what will it do? So it returns the items which are in both the sets. Apple is in both the set, it returns apple. So by now you can get the idea that why these are so famous, why these are being used in mathematical operations. All of us in our childhood, we have studied, like, in maths we have studied A intersection B, A union B, A complement B. So all these set operations we have studied in our childhood in maths. So here is where it, it is very applicable, it comes into picture. Now next we come to the intersection update function. It removes items that are not present in both sets and returns the original set. So again the same thing. The first case was returning a new set, and this case is returning the old set, but with the common item. So what is the need for doing intersection, and what is the need for doing intersection update? That is as per your requirement, because sometimes you will be required to use intersection, sometimes you will be required to use intersection update where you need to keep the original set. So that is as per your requirement. Next we come to is disjoint function. So the is disjoint function, what will the is disjoint function do? It will return true if none of the items are present in both sets. Okay. So what happens is that x and y are two sets, okay, and it is, you can see that it is returning true here. So why is it returning true here? Because see, these are two unique sets. X does not have any item which is in Y, and Y does not have any item which is in X. So they are completely disjoint. So that's why it's returning true. Now we come to is subset. Is subset will return true if all the items of X and are present in Y. So from here you can see, of course by now you can understand why it is returning true, because all the items of X are present in Y. ABC are all ABC, everything is present in Y. So Y has ABC and it has its own items. So basically X is a subset of Y. X is within Y. Okay. So now next we have is superset. So this superset function, what will it do? It returns true if all the items of Y are present in X. So now in this case we can see that all the items of Y, that is A, B, C, are present in X. So basically X is a superset of Y. Okay. So basically X is a superset of Y. Y contains Y has whatever elements Y has, they are all present in X. X is a superset. So this is the superset and subset functions. Okay. Next we have the symmetric difference and the symmetric difference update. So the symmetric difference, what is the symmetric difference? It returns a set that contains all items from both sets excluding the common item. So this definition is very, very clear. Okay. So X and Y are again two sets, and we're taking the symmetric difference of X and Y. So as you can see, it will return, what is happening is that it's returning all the items. It will return a set, it's returning a new set that contains all the items from both sets excluding the common items. So the common items here have been neglected. So here you can see apple is common. Apple is the only thing that's common, so that will be neglected, and the rest of the items will be printed. Sorry, not printed. The rest of the items will be stored in that set. Okay, and again the symmetric difference update is again the same thing. The old set will be updated. There will be no new set. There will be no new set which will be created. The old set will be updated. So basically, all these properties make the sets a very important data structure for mathematical operations. Okay, that is why these sets are important for mathematical operations. Okay, and we have another very important mathematical operation here, method here, that is a union. So it returns a set that contains all the items from both the sets. So basically, we all know what is A union B. That means returning a new set with all the items. So as X and Y are two sets, Z, we have taken we take Z here, and Z contains all the items. So all the items of x and y. So basically these are all the set operations, okay, which make it very useful for the mathematical operations. Now we go to the last data structure, that is dictionary. So dictionary, basically, what is the syntax for creating a dictionary? What is the code for creating a dictionary? The dictionary is always created with this curly braces. Now a set was also being created with this curly braces, but what is the difference between the dictionary code and the set code is that within the set we just had items. In a dictionary, we have keys and values. We have pairs of keys and values. So here you can see that debit card and credit card, these two are the keys, and 5 and 10 are the values. So you can see in the first line of code, the first code, how this dictionary has been created. Within the curly braces, debit card, and then how many debit cards? 5. Credit card, how many credit cards? 10. So this is how the dictionary is created. It is displayed in this way. So now if I want to update the dictionary, how will I do? How will I update a dictionary? I want to update it. So this is how I update a dictionary. I'll just give the syntax, write the key, and then add the number of values, add the value with it with the key, and then I'll print it. So now you can see is that the debit card was earlier 5, it had a value 5, and now the value of the debit card has increased to 10. So the value associated with that key has been increased by 5. Now if we want to retrieve a value, okay, now I have all these keys and values, all these keys within my dictionary and the associated values I'm having. Now if I want to find out how many debit cards do I have, so so what I do is that I print this, I print the debit card, that is I print the name, I print it like this, the name of the dictionary and then the key value within square brackets. So that gives me the values, that gives me the value. So again, this clear function, what will it do? The clear function will again, like as we saw in the previous cases, the clear function will clear the entire dictionary, and there will be no items left in the dictionary. And the copy function will copy a dictionary. Sometimes we require to copy a dictionary. Okay, we require to copy it, so it will copy it to another dictionary and create this new dictionary. And now, what does this from keys function do? So this is a little bit important. So it returns a dictionary with specified keys and specified values. So you can see that what this from keys function is doing is that we have x and y here, okay? So what this function is doing, basically, it's returning those keys with the specific value. So it's returning all these keys with a specific value. All you can see that key 1, key 2, key 3, all these 3 keys are having the same values, the specific value. So this from keys functions returns the keys with a specific value. Now the gets function. So the gets function, what does it do is that it returns the value of the item with the specified key. So in this syntax, you can see is that it's returning, I am having this key here, these 3 keys I'm having, brand, model, and year, and their associated values. So the get function is what is helping me, it's helping me to get the value of that key. So the value of model is what? Mustang. So I'm getting Mustang here. Now we have keys and values. So basically, by now you all know that what do we mean by keys and values? Okay. So this syntax. What does it do is that cards.keys and then the bracket. What does this syntax do is that it will list all the keys of the dictionary. And this syntax card.values, this will list all the values. For example, for some reason, I have a dictionary and I want to check all the keys of the dictionary. I want to see what all keys are within my dictionary. So I use this syntax. And likewise for values. Okay. So now we have the update function. So the update function is again like the similar previous cases to update an item for dictionary. We have to update, when we want to update the dictionary. Dictionaries are mutable, so they can be updated, they can be changed, they can be shortened, it can be increased. Okay, so this update function helps us to update it. Now we have the set default function. So the set default function, what does it do is that it returns the value of the item with the specified key. So the set default function what it's doing here is that uh, it's returning the value of the item with the specified key. So set default we have here the car, the dictionary's name is car as we have from previous example, and what it's doing is that it's returning the value of model. It's returning the value of model, and we are getting here Mustang. Okay, so it returns the value of the item with the specified key. And now the pop function, as we have seen earlier, the pop function helps us to uh, remove the items from the dictionary. And obviously, the pop function will not remove any item; it will remove only the last item. So here, the last item, when you use this pop function, the last item gets removed from the dictionary. So thank you. That was my presentation for today.
Uh, Thank you, Anish. We are really thankful for your time in for the webinar, and we are looking forward for our viewers if they have any questions regarding the topic that was conducted today. Anish is there for you to clear your doubts. You could wait for a minute or so to see if any questions are there from our viewers.
Yes, sure, sure.
Well, I think the questions are not so much. I hope it was a good presentation sharing among to you, Anish, and I hope our viewers also
Yes.
like the video. Anish, would you like to say something on behalf before concluding the webinar?
Yeah. Actually, my presentation, yes, I would like to say something actually. That is, this presentation which I prepared was actually basically for the beginners in Python. So, this presentation is basically for beginners who do not understand the concept of loops and basically who have any who don't have any basis in computer programming, who are new to computer programming. So they don't have any concept of hoops. They don't know what is hoops, what does it mean, and then we know that nowadays oops is a very trending concept. So most of the programming languages uses the oops concept. So Python data structures, like data structures are the data structures which I have said is mostly those are usable. Those are we find it in most of the programming languages. But mainly why I elaborated mostly on the data structures is that these so that the people, there are many students right watching this, so basically those students should get a good idea of what these data structures are and how to use them. That is why I elaborated on those functions specifically. So these functions look very small, they look like very small functions, one word functions, but they are very helpful while we are writing our code. They are very helpful in we use them in lot of use to do many things. So it's very helpful for a programmer. So that's what I want to say.
Okay, Anish. Thank you for your views and your talks about OOPS, the importance of it, and why students should study about this thing. Um, we'll conclude the webinar today right now. Your PPT was quite elaborate and quite descriptive, and we thank you for your time. Okay, I'm concluding a ceremony right now. Thank you, viewers.
Yes.
I'll see you tomorrow, as we have another webinar tomorrow being held at 3 o'clock with instant access to healthcare, which will be done by Mr. Mondal. So I hope to see you tomorrow at 3 o'clock. Okay. Thank you. Thank you, everyone.